谁帮我用上网？
哦。
不知道为什么都上。就没有其他人来修运过器设计的课，今年还要用这些去做电路，就只剩下我也很想跟外界内容的。OK，Thank you，Thank you。OK，Thank you。
Last week I explained the theory about Smith chart, right? Do you guys remember? But maybe you briefly understand will be fine. If you briefly understand. The most important thing is how to use Smith chart. How to use Smith chart. It's extremely important. And if you are an RF engineer, you must understand at least how to use Smith chart. Okay. Last week we have a question. You guys remember? Do you still have the number? Do you still have the number, the answer you calculate? Do you? Maybe we can go back. We can check the answer. We can check the answer to prove you understand or not. Okay. One important thing is that you need to prove you understand. Not like you don't just satisfied in this class. Understand? This is not a class about self-satisfied. You must not only understand, and you need to give a correct answer. This is very important. Okay? This is not just like a show. You feel fun, you are satisfied, you understand my punchlines, then that's it? No. You need to give me the correct answer to pass the class. Okay? And one of the important things is how to use the Smith chart. What can Smith chart do? So let's go back to, okay, thank you. Let's go back to the same question I gave you last week. This is the same one. I told you to do that by yourself, but it's more, I will feel more safe that you understand or not, okay? Okay, so the question is here. First of all, you need to understand what the question is asking about. First of all, you need to understand what can Smith chart do. So a Smith chart means there is a load. Okay? Then this is a question, the start of the question. For this question, the load is 40 plus 70, J70. It is a complex number now. It's not just a pure resistive. It's not a pure resistor for this impedance. This is a complex number because this is a system of AC. Okay? So this load, it is a complex number connected to a transmission line, and I have high frequency signal on it. This transmission line has the characteristic impedance Z0 equals to, okay, for this case, 100. Okay, and let's just skip the part about the relationship about the physical length L or beta. I just directly use the length. I use the wavelength 0.3 lambda as the wavelength, and this one is relevant. They have some relationship to the physical length, how long it is, okay, in the real world, how long it is, and also what is the propagation constant, or you say K of this transmission line, okay. But in the end, you can translate to lambda. This is one of the important parts. If you want to use it, maybe you have get a problem to transfer from lambda and the L, right? If you want to design, you must to make it. You have to manufacture the line, right? So how long your line is? It is very important. But for this question, it's very easy question. So I put lambda. We can change this one to some frequency and the physical length. You transfer to lambda. This is one part of the question we deal with before, right? This is a question we deal with in before midterm. Okay, but now we just use lambda. It's easy. Okay, so according to this one, what is the input impedance when I have this line? If you are thinking in a way of DC or low frequency, you will feel like, okay, this impedance is the same as this impedance. That's a way you think in thinking of a low frequency. But in high frequency, a lot of voltage wave and current on this transmission line. So the input impedance is changing according to you have the physical length of the line, so you will change it, okay? We should understand that. And what is Z in? This is Smith chart. This is how Smith chart can help. Okay, we can use Smith chart to get what is Z. So at the beginning, we need to know if there is no transmission line, what is the starting point at here if there is no transmission line. So you should find out your answer here. This is the load impedance and normalized by your characteristic impedance of the transmission line. Okay, you divide your 40 plus J70 divided by 100 ohm, so you can get a number from here. I find some of you don't know how to find this point, right? But I hope now you already understand, okay? So if you still don't understand, don't wait until final exam. You should understand that it's not so hard because all of you have you have Smith chart. You should very confidently know how to find out this point. So this point is the same point here. Okay. Then I use the ruler put that on to draw a line. One of the side is from the center of the circle, and the other side is your starting point, and you make this line, okay? Because when you have a longer transmission line, your angle will be negative. Remember, theta equals to minus 2 beta L, right? So the clockwise is how the direction of the clockwise is in the same direction of when you increase your length of transmission line. So you find out a number from here, and then you find 0.3, and then you use the index for the outside circle, and then find out where is the location of point 2. Okay, just review it. There's nothing new so far. And then use your ruler. Use your ruler to find out. And then this is how we measure 0.3 lambda. Use the index of outside, and then use a ruler from the index for 0.3 lambda. Make another line, and then use your compass to make a circle. Because on the transmission line, your reflection coefficient is the absolute value of your reflection coefficient is the same, right? So you find 0.2, and then you know the number. What is the answer for you guys? Do you guys review after you go home? What is the answer? Johnson, do you remember your answer? What is?
Z in equals
Z in, okay.
The real 35 plus
35 plus so,
minus minus J 68.
J
68.
68. Okay, anyone else has different question? Answer is fine. If you are correct, I give you extra point. Anyone, raise your hand. You have different answer. This is Xiongsan. Okay, anyone else? Do you want to try? Anyone? Do you have different answer? No? Come on, what did you do after the class? You are not satisfied with my class. You have fun.
And use ruler, the VSW are almost.
No, don't stop. I just want the.
Okay.
Okay. 37.
Almost.
Minus J.
61.
61. 61. Okay, let's find out someone very close and give him extra point, okay?
The second is the use formula calculated result.
This one is a calculator result? You sure? You use the Swiss, okay?
那公式的
36 minus also 61. 61.1. Who else?
34.
34.
Almost is there.
Okay, so you guys got very similar result.
Minus J 61.
J
61.
61. Okay, everyone is close. Okay, maybe we can check. Okay, let's check. Okay, you can use. There is a website on here, Smith chart tool. Okay, you can use this one. Let's try. Let's play. You can do more exercise. Okay.
Okay.
So the question is, what's the question? 40 plus J70. 40, I don't care about frequency, it doesn't matter, I will use lambda, okay? So the load, it is 40 plus 70, okay? And my characteristic impedance is 100,
Yes.
okay? Let's do the calculation. Okay, so the starting point is here. Okay, and my transmission line, I make a transmission line here. I click. So I connect to a transmission line, and the transmission line I use lambda. It is 0.3 lambda, and the characteristic impedance is also 100, right? So, 啊？
这个应该不是0.3，是从这里加0.3。那这样是输入下面这个值。
对啊。
什么意思？
那不是输入0。
What is the question? You need to use 0.3 lambda. The total circle is, what is it? The total circle is 0.5 lambda, right? And this is 0.3 lambda. Makes sense, right? 你听得懂意思吗？ Okay. So for point 2, for here, your answer is here, and then you can see the answer
36.
36.5 minus 61.1. Okay, this is a.
Almost.
Okay, you guys are close. But this one is too bright, right? Try others, they get it closer answer. Okay. So now you have a website, and then also I think most of you have ADS. They can do the same thing.
Yes.
And you can easily do this one, and then you can get right answer. Good luck for your final exam, okay? So this is one of the things. There are more. You can see that if you know how to design an amplifier to do the match, there are more questions you can do, because you can see there are a lot of different stuff you can add, right? To match your circuit. Let's change to our question from this one to an easy one, okay? If your ZL, let me change the question. If ZL is 100, okay, and you connect something, you connect to a 50 ohm transmission line, and you want to make it 50 ohm. What can we do? If I add one more inductor in that, what are the answers? Okay, you can still use your Smith chart to do it, and also you can still use your equation to calculate. So, add the inductance. This is another question. You use not only transmission line. And I will ask you about or lambda equals to something. and I want to match 100 ohm to 15 ohm. What happened on your transmission line? Okay, let's start this question. It's good we have a whiteboard there, and I can use dual screen. It's nice. So if your load is 100, and I don't have this line yet, and your characteristic impedance of your transmission line is here. Your point 1 is at here, okay? It's 2 from your Smith chart you can find. You use the 2 here. This is the starting point. This is the point here. What is your goal? Your destination, you want this point go to 15 ohm middle, right? I want 15 ohm. Okay, so I want to move here. Can I just do that? No, there's no way go here. Okay, so first of all, I connect a transmission line which is also 15 ohm. So your starting point will become, let's do that, I click and I use 15 ohm, and no matter I use, I can use different units. Lambda is 1 lambda mu by 3. So I don't know how long it is, but if I change lambda, I connect a transmission line, it is always a circle clockwise from here. Okay. If I know I want to go to this point, what can we do? I can go to some point down here. For this circle, what is this circle? For this, I think it's a black line, a thin black line. For this circle, all the impedance on it is 50 ohm. The real number of the impedance is 50 ohm, right? But they have different imaginary number. What I need to do is I go here and I cancel the imaginary part to 0, and I can go back to 50. So what I can do is I try to change 0.1. Is that close enough? Okay, maybe a little bit too low. So I change to 0.95. 0.1. Okay, maybe not enough. So I change to 8. Okay, you can see. You can see it touched the number of 50 ohm. The impedance is 50 ohm, but the imaginary part is not 0. What I need to do is I delete the imaginary part by using a series of inductance. So I add one more series inductance here, then the line will follow the circle here. Okay, then what I need to do is I change that to maybe 2, or 2 is too much. 2, not yet, 2.2, not yet, so 2.3, okay. So I go from 100 to 50 ohm. Let's check what is the output impedance. So output impedance is 50 minus 0.0573. This is output impedance. Okay, It's very close to 15 ohm. Okay, so there are different ways to match from, okay, this is the left and the right is different. Okay, the left one is 15 ohm and connect to a transmission line and the inductor. So your line is going to here and found the red circle, go back to 15 ohm. And then you can also use this one. This is use the capacitors to make to cancel the positive. So what we can do, if here is a negative line, so you make your transmission line longer until touch another side of this circle, then you can use your capacitor to come back to 15 ohm. This is another, and you can also use the website to, or your ADS to find out the values. Okay, so for this one, these two are more, this is different because I want to use the parallel. I want to connect your lab element in parallel to match. Sometimes you will need a parallel, right? If you want to use a parallel, you need to use the circle. We call this the Y Smith chart, right? This is a circle here. Another red one is another. This is a Z Smith chart, and then I use another like a mirror of the Z Smith chart. I use a Y Smith chart. I connect that to maybe the gray one and go back here. And then for this one, if I use a capacitor in parallel, I go to the up here, another side, and go back. Okay? So I show you for different ways. It depends on you want to use your lamp element to do a match in parallel or in series. Okay? It's not so hard, and especially if you have the tool, you can try to check if your method is correct or not. And you can change your input impedance to any number you want. Okay, and this is kind of match. And one of the important thing is, this is the result. You use the different element to do a match. Maybe you should consider about the bandwidth. Okay, bandwidth is one of the issue. So maybe you can try to see. There are many different ways to match an impedance, but all of them will have different result of the bandwidth. Okay, and one of the important thing is the stop. Single stop or double stop. Stop. This is it. What is stop? What is stop? If you guys you have experience about design amplifier, you saw this before. This is a design of the amplifier. For this line, this line is a stop. This is an element to match, and you don't need to solder anything. You just use a machine to manufacture the line, and they provide a function of matching element for your circuit, and you can design your maybe amplifier or any other thing, maybe filter as well and other. Okay, this is the stop. What is this? What is this? Stop is you are making. Okay, let me directly go to. Okay, in your textbook, they talk you like, oh, there are shunt stop and a series stop. And I think for our case, we are making shunt or a series. I think we are making shunt. I think it's shunt stop. Shunt stop. Okay. So other than using your lump element to match, you can use the stop. The reason is how to use that. If let's look at the Smith chart, we look at the outside circle of the Smith chart. Can anyone explain what happened on this outside circle? What is this? Let me call someone's name. I need some response. I use Julia. Let me repeat my question. This is a Smith chart, right? What is this circle? What is the impedance on this circle? What is this circle means? What is the location on the edge of the circle, or maybe you can say the circle of radius equals to 1. What is the meaning of this circle? Okay, let me find someone to answer my question.
Relation
What is a circle?
resistance. The normalized impedance real part resistance equal 1.
Again?
The normalized number impedance real part resistance equal 1.
Okay, let's ask another student to see if they have different answer. Okay, you think the normalized real impedance is 1, right? For the outside circle, right? Okay, right? Is that your answer, right?
Yeah.
Chen Zixuan, do you have different answer for Smith chart for the outside? For the radius equals to 1. What is this circle? If you have any point on this circle, what does that mean? If you are doing your research, you're making a circuit and you measure something on a circle, or you simulate your circuit, you have some point on a circle. What does that mean? Okay. What does that mean on a circle?
2分之一波长度为2，所以它随着波长不同改变。
My question is about the impedance. What is the input impedance on a circle?
0 infinite 0 infinite
自印。For this one,
0
no, right?
infinite 0
What is 自印? Input impedance.
real number or normalized number?
Either way. Just tell me what it is. Yes, student, you want to try? The wavelength is not relevant. You can always change your the length. It depends on your physical length, right? But my question is, what is the input impedance? What is the impedance? If that is, you have some impedance on the circle. What is the meaning?你的 impedance 如果是在这些 location 的话，代表 the meaning. You do some match, right? Sometimes maybe you go too far, you use something and then you touch this one at some point, at some end, right? What does that mean when you touch it?
我们中文讲，
Okay, sure.
红色的圆圈是代表着10度，蓝色的那个像放射线是代表着10度。
I don't want an explanation. I want an answer. What is that circle? What is that circle? So the circle means outside. This circle, not inside. You are talking about every circle. I mean, what is the answer for this? The outer circle with radius equals to 1. 半径1的圆是什么意思? You want to change your point? Respect. Respect this answer first, and then maybe I will give you opportunity. So what does that mean?
是一个正规化的
So what does it mean? I know it's a circle on the paper. Very circling. What does that mean?
应该算好。
啊？
就是蓝色那个是虚部。
No.
那个，你说那个半径为1的圆。
Yeah, what does that mean?
就是蓝色的，这个那张图那个蓝色那个。
what does that mean?
它是 imagine part。
Every part they have imaginary part, right? But you are close. But your answer is not.
加一个范围。
first, okay? Maybe you know it.
反射系数为一。
That's correct. That's not what I want. I'm asking about what is the reflection coefficient. So what is my question is what is the input impedance if you have the reflection coefficient what? What is the input impedance? Yeah, your answer is correct, but I want different answer. Gamma, absolute value of gamma is 1, yeah? That's correct.
Yes.
But my question is not that. What is the impedance of that? It's not a simple question. There is no easy answer. But there is some.
You can only use imaginary part.
So that means what equals to 0?
Your part is
Yes, right answer. For this circle, what is this one?
Infinite.
Open.
Open.
What is this part?
Short. 0.
Short. What is other part? Pure inductive. Open. Pure capacitive. Short. Pure inductive. So there is no resistance on the circle. Okay? According to the technique we are using, you can use a transmission line. If that is an open transmission line with some length, you can change. You can use the length to obtain the value of capacitance we want. You can make a capacitor by using your open end. Okay? You use an open end to make a capacitor in parallel with your original transmission line. Or if your transmission line is long enough, it is an inductor. You can use your open end to make an inductor or capacitor or inductor. Or you can use a short end to make an inductor or capacitor. You don't need to use your lump element. You just use your transmission line to make more accurate value you want. Understand? And this is what we do to design here, okay? So this is a stop line, it's open. So open is close to capacitor. Use open, it is easy to make a capacitor. And if it's very long, maybe you want to make an inductor. But maybe it's easier, it's shorter to make an inductor if you use a short end. This actually is you think like a capacitor. Okay? It is a capacitor in parallel with your main transmission line. It's in parallel, connect here. You have there is a parallel inductor, capacitor. Okay. Yeah, fun, right? Once you understand, you know. And then the more fun here is you will have more questions. So, another question, if you want to match a new load, ZL equals to 60 minus J80, my question, I will give you like, what is the short single start? Shortest, I mean, if your transmission line at half wavelength, it will be a circle come back, right? So I will ask, the question is the shortest, so my answer is, there is only one answer. The shortest short single stop, only one stop, is from a short. And the shunt tuning network with the shortest transmission line, D. And I want to match to 15 ohm. This is one of the question. Okay, let's take a rest and you can get extra light in the, okay. And I think all of you can also get a point.